Basically, what we're doing is covering basic concepts in acoustic phonetics or sometimes auditory. One of the preliminary concepts in acoustic phonetics is the concept of formants or formant frequencies. In science, the way we do things is making them objective so that everybody else can examine our research and then question it. So basically what we do is we try to have methods that are as objective as possible. And one way to do that is put things in pictures and, more importantly, in numbers. So we can measure things. Phonetics is also no exception to that because we're trying to apply the scientific method to the study of speech sounds. So what we do is we provide pictures of sounds. Yes, we can provide pictures of sounds. And we can describe speech sounds using numbers. How do we do that? Phoneticians do so by analyzing sounds in terms of their frequencies, or to be more specific, their formant frequency. So what is a formant? So the air goes through the vocal folds, the production of sound begins, but the sound is too weak. We need to make it stronger, make it louder. How do we do this? When you play an instrument, a lot of instruments usually have a resonance chamber, which helps resonate and amplify the sound. The same happens in our speech organs. So the sound after the vocal folds is amplified in the cavities above the larynx, which is after the larynx. And larynx is the space or the voice box where the vocal folds are. So these cavities are the pharynx, or it could be the oral cavity. These are examples of those cavities that amplify speech sounds. So these cavities resonate certain frequencies, but they also do not resonate certain other frequencies. These frequencies that are resonated here are called formant frequencies. Formants or formant frequencies are peaks or maximal points in the sound spectrum. In this picture, you see two charts. The one above is the front vowels. The one below it is the back vowels. On the horizontal axis, we have the list of the vowels. On the vertical axis, we have a bunch of numbers which actually indicate the frequency in hertz. So we have 1000, 2000, 3000 hertz. As you go up, the frequency increases. For example, for the vowel E, as in the word C, there are three frequencies that are mentioned here. The frequency 280, 2250, 2890. These are three formant frequencies that identify the sound E, or with which we can identify the sound E. The first one at the bottom is the first formant, the second one is the second formant, and the other one is the third formant. If you look at the sound U, as in who, you see that it has the three formant frequencies are different. It actually starts at 310. Then the second frequency is much lower than the second formant frequency of E. The third formant frequency of U is equal to the second formant frequency of E, which is 2250 Hertz. Each vowel is associated with three numbers on top, which are three formant frequencies. Vowels A and O have the same third formant, but they differ in their first and second formants. However, certain frequencies between two given vowels may be much closer to each other than the same frequencies between another pair of vowels. For example, vowels A and U have very close second formants, 880, 870, while the second formant of A is much higher. You don't need to memorize these numbers. You just need to look at them and see that every vowel here has been identified with three formant frequencies. How do we get these numbers? There are certain computer programs, and they're often freely downloadable, that can help you analyze sounds by showing their components. For two of these programs are Audacity and Pratt. Using such programs, you can get a visual on the sounds that is known as the spectrogram. You can then analyze and interpret the spectrograms in order to understand sounds with objective numbers. This one is a spectrogram. If you use Audacity or Pratt or see these programs, what is this a spectrogram? First, let me tell you that this is a spectrogram of the sounds in these words. A spectrogram of the words heed, head, had, hod, hood, and hood, as is spoken by a male speaker of American English. If you look at the vowel for hood, the horizontal axis from left to right shows the time in milliseconds, or intervals of 100 milliseconds. The vertical axis from bottom to top shows frequency in hertz. Time is reset in a separate frame for each vowel. There's a third dimension to this spectrogram, which has nothing to do directly with the horizontal or vertical axis, but it has to do with the degree of darkness of the spectrogram. You see, certain areas of these spectrograms are darker than the other. For example, for the vowel U, the intensity of darkness is much less than the ones for the vowel A, as had. So this intensity is also important, which gives a third dimension. You can see that the vowels in each of these words have been said in different durations of time. So this is an interesting thing. You see the vowel as in hood, has been said faster than the vowel U. So this is why people usually say U is longer than But the point is, although it typically is the case, the difference between the two is not the duration, it's also the place of articulation. You can see that the vowels in each of these words have been said in different durations of time. You can also see that each formant may have a different degree of intensity and looks like a horizontal bar. For each vowel, you see 3 arrows from the bottom to the top, and in the same order, they're the first, second, and third formant frequencies. And you can kind of abstract each formant frequency as a bar. If you look at the chart, you will see that there are extra bars other than the 3 formants. Why don't we associate them with formant frequencies? Because they are not significant for the study of linguistic sounds, speech sounds. The position of those formants may differ across the speakers and are indicative of a person's voice quality. So if you say the word heed and I say the word heed, we will get spectrograms which are slightly different.